Hello everyone. Today we are going to discuss about what is a vector database. So what is a vector database? It is a specialized database which is designed to store and index and query dense vector embeddings efficiently. So its main functionality is to store vector embeddings and perform similarity search to find most similar vector according to the user query. So it can be scaled to billions and billions of vectors. And for example, there are different vector databases available. Some of the open source databases are ChromaDB, VespaDB, Quadrant, Milvus, and Weaviate and Pinecone are vector databases which have both open source and paid licenses available. And some other databases also available for vectors embeddings like Elasticsearch, Redis, Single Store, like that. So why do we need vector databases? So we need vector databases because traditional databases are inefficient for unstructured high dimensional data like vector embeddings or word embeddings or any kind of image or video embeddings. So it has a limited support for similarity search and semantic matching. But in AI applications, we have heavy requirement for similarity search and semantic matching, like retrieval augmented generation. There we need to find the most similar documents based on the user query from the vector database. So that is why we use vector databases which are optimized for dense vector storage and search. So it supports very fast and scalable similarity search over billions and billions of vectors, which are numerical representation of different kinds of text data or video data or image data, etc. So in traditional databases, we store the data directly, but in vector databases, we store the data in vector format. So it convert the data into vector format and then store it in the vector database for easy uh, semantic search or similarity search. So how it works? So input embeddings are generally created using uh, different kinds of deep learning model like BART for text processing or Llama embeddings or in OpenAI embeddings or Google text embeddings. So those kind of models are used to convert the uh, vectors convert the input data into vectors. So based on the requirement. So then that is some indexing algorithms are used for to index it into the vector database so that we can efficiently search for it and retrieve it whenever required. So once a user passes a query, that query is converted into vector and we find the most similar vector to that query for retrieval. So this is called similarity search. After that, we can get retrieve top 5 or top 10 vectors or documents according to our requirements. And in case of break, we can pass those documents to the LLM to create use or create the final result. So now, how to choose a vector database? So there are several key factors. So performance is one of the important factors. It should be fast, scalable, and latency should be low, and it should support text, images, or audio embeddings according to the requirements. So if we have multimodal requirement, then your vector database should have multimodal support like text embedding, image embedding, audio embeddings. But if you are using only text dataset, then only text embeddings are needed. So based on the requirement, you have to select it, and indexing should be also efficient so that the vector database search and other algorithms works efficiently, and also there should be balance between open source and managed option also, because open source databases, while they are free, but it is very hard to manage those databases in your own uh, in-house system sometimes for large applications. So in those cases, we can use the managed options or the closed source option, which are like paid version of different vector databases. So, but in this case, we need to be mindful of the cost. And also, security is an important issue. So, the vector databases we are using, it should have a robust encryption and access control, so that no data leakage and data security issue happens. And it should also have active community support and clear documentation for easy understanding and user. Uh, it should be user friendly. So this was all about the vector database introduction. Hope you all learned something about vector database today. Thank you.